All right, so we're doing a deep dive today on the Shapiro-Wilk test.
Okay.
And you sent over this really interesting article from RStudio Data Lab.
Yeah.
And honestly, it's got me like rethinking how much I thought I knew about getting data ready to analyze.
Yeah, the Shapiro-Wilk test is interesting because you really have to use it as like a prerequisite for a lot of other analyses.
Okay.
Like, you know, when you see that sign at like an amusement park ride that says like, you must be this tall to ride.
Right.
It's kind of like that.
Okay, so you're saying Shapiro-Wilk is like the height requirement for data. I'm kind of intrigued. Tell me more.
So a lot of statistical tests, like ANOVA,
Okay.
which just to be clear, that's a test that compares like averages between groups.
Right.
Those tests a lot of times depend on your data being something called like normally distributed.
Okay.
The Shapiro-Wilk test
Yeah.
is how we check to see if our data actually fits that description before we go any further.
So it's like the gatekeeper, making sure the data is actually statistically sound before we, get ahead of ourselves.
Yeah.
So the article talks about like the null and alternative hypotheses.
Right.
And I'll be honest, those always kind of trip me up a little.
Sure.
Can you break those down?
So think of it this way. The null hypothesis is like our like default assumption
Okay.
that our data normally distributed.
Okay.
It's like we're just going to assume that a coin is fair unless we see it land on heads like 10 times in a row.
Right.
So we start with that assumption. And then the alternative hypothesis is obviously the flip side of that coin,
Okay.
where our data might not actually be from a normal distribution after all.
So in a perfect world, we want the null hypothesis to be true.
Yeah.
Like we want our data to be normal. We want that to be correct.
Exactly. And the way we figure that out is through that magical p-value.
Okay.
And this is where things get really interesting.
Okay.
Yeah. So if we have a high p-value,
Okay.
which is usually above that 0.05,
Right.
then that means our data probably is normally distributed.
Okay.
But if we've got a low p-value, like say 0.01 or
Okay.
something,
Okay.
that's kind of like a red flag.
Okay.
It means our initial assumption might be wrong,
Right.
our null hypothesis,
Right.
and our data might not actually be, playing by the normal distribution rules.
Which could totally like mess up our analysis if we just barrel ahead without realizing it.
Exactly.
So the article mentioned that this can be influenced by how much data you even have to work with in the first place.
Yeah, for sure.
So does that affect this whole p-value thing?
Absolutely. So like imagine you're trying to judge a restaurant,
Okay.
but you've only looked at like 2 reviews online
Okay.
versus if you looked at like 200 reviews.
Right. You're going to get a very different picture.
Totally. With a small data set, the Shapiro-Wilk test might not be sensitive enough to pick up on like subtle things that are actually different from normal.
Interesting.
It's almost like trying to hear a quiet melody
Okay.
when there's like a lot of other noise around.
I get it. And then on the flip side, if you have a ton of data, even tiny meaningless differences might set off the test like a false alarm.
Exactly.
Like if you got the wrong color sprinkles on a cupcake,
Right.
statistically speaking, that's not a big deal.
Exactly. And that's why the article really emphasizes using the Shapiro-Wilk test alongside like visualizations,
Okay.
like histograms
Okay.
and QQ plots.
Okay, so we're bringing in the visual aids now.
Yeah, because those can help us see the bigger picture.
Okay, I'm intrigued. Tell me more about these visualizations.
So a histogram, you can kind of think of it like a bar chart
Okay.
that shows us how often different values show up in our data.
Okay.
So if that histogram ends up looking kind of like that bell-shaped curve,
Right.
then that's a good sign
Okay.
that our data might actually be normally distributed.
So it's like that classic bell curve we always see. It's like, okay, that looks about right.
Exactly.
Okay, what about those QQ plots? I've heard of those, but I don't really know what they are.
So those are a little more complex, but think of it this way.
Okay.
It's like comparing our data's like outfit
Okay.
to the dress code
Okay.
of a normal distribution party.
I like where this is going.
So if all the points in that QQ plot line up nicely along a diagonal line,
Okay.
we know our data is dressed appropriately.
They're ready to party.
Exactly.
Got it.
The article actually gives a really cool example of how this all comes together
Okay.
in a real-world scenario.
Okay. I'm listening.
So these researchers were studying
Okay.
apps that are designed for wine tourism.
Okay, hold on. This is my kind of study.
Oh, yeah.
Tell me everything.
So they want to know if these apps are actually making people's experiences better.
Okay. Makes sense.
But before they could analyze their results, they needed to make sure that all the data on, like, how long people were using the app,
Right.
what features they interacted with, all that kind of stuff,
Right.
that was normally distributed.
We don't want to jump the gun
Exactly.
if the data's not right.
Exactly. They don't want to say, oh, the app is amazing if they're working with bad data.
Exactly.
So they ran their Shapiro-Wilk test, and found that their p-value was way above that 0.05 threshold.
Okay.
Plus, they created some histograms and QQ plots,
Okay.
and those backed up what they were seeing.
Cool. So everything's matching.
Everything's lining up so they know they can move forward with actually analyzing how effective the app is.
They got the green light.
Exactly.
I love it. Okay, so this is like a real-world example of how we're using this test.
Yeah, and they talk about how this test is used in all sorts of fields,
Okay.
like environmental science,
Okay.
where researchers use it to study things like water quality.
So this seemingly very obscure
Yeah.
statistical test
Yeah.
is actually being used to,
Very practical.
for very important analyses.
Yeah, it affects all of us.
It does affect all of us.
Yeah.
Very cool. Okay, so it's important we've established that.
Yeah.
But reading through the article, I'm also seeing that there are some limitations to the Shapiro-Wilk test.
Yeah, for sure.
So what are some of those things that we should be aware of?
Of course. One thing to remember is that Shapiro-Wilk really shines when you're looking for those deviations from normality like we talked about,
Okay.
but especially when you're working with smaller data sets.
Okay.
And there are other tests out there,
Okay.
like
I'm listening.
like the Kolmogorov-Smirnov test,
Okay.
which honestly, that's a mouthful.
It is a mouthful.
But that one might be better suited for when you have larger data sets.
Okay, so it's like we're talking about having different tools in a toolbox.
Oh,
You wouldn't use a hammer for every single household project, right?
Exactly. It's about choosing the right tool for the job.
Right.
So the article highlights how that Kolmogorov-Smirnov test that I just butchered,
It's okay, we get it.
that one's often better when you're working with like huge data sets
Okay.
because it's not going to get thrown off by every little tiny insignificant difference.
So it's less likely to give us that false positive just because we happen to have a ton of data points.
Exactly. It's like it understands what actually matters
Okay.
more than like the Shapiro-Wilk test would in that case.
Gotcha. This is really making me think about like how important it is to have a really like well-rounded statistical toolkit.
For sure.
You know, you don't want to just lean on one test every time.
Yeah, you need to know the strengths and weaknesses
Exactly.
of all your different approaches.
And when to use what.
Exactly.
So interesting.
It's a huge field.
Yeah,
There's so much to learn when it comes to data analysis.
totally.
But honestly, sometimes, like the article reminds us, sometimes the simplest approach can be the best one.
Okay, like what? Tell me more.
Just visualizing the data,
Okay.
like we were talking about with histograms and QQ plots,
Right.
that can be so powerful,
Yeah.
no matter what statistical test you end up using.
Right, because then you can actually see it.
You can see the patterns.
Yeah.
You can see the trends.
Totally. Instead of just like these abstract numbers.
Exactly.
Yeah. It's like if you were looking at a painting,
Yeah.
you'd want to see the whole thing,
Yeah.
not just like one tiny little brush stroke.
Exactly.
Yeah. Okay, so for anyone listening who's like maybe feeling a little overwhelmed with all this talk about statistics,
Of course.
if you're going to remember one thing about the Shapiro-Wilk test,
Yeah.
what's like the key takeaway?
I think the most important thing to remember is before you jump into any kind of like complex data analysis,
Okay.
you got to make sure that your data is actually appropriate for that.
Gotcha.
And the Shapiro-Wilk test can help you do that
Yeah.
along with those visualizations.
So important because if your data's bad,
Yeah.
your analysis is going to be bad.
Garbage in, garbage out.
Exactly. It's
Oh.
like you're building a house on a shaky foundation.
Exactly.
And nobody wants that.
Exactly.
Awesome. Well, this has been so eye-opening.
I'm glad to hear it.
Thank you so much for joining us for this deep dive on the Shapiro-Wilk test.
Yeah, this was fun.
It was really interesting to kind of like unpack this test. For sure.
It seems small, but it's actually mighty.
It is.
And it can really make sure that you are drawing the right conclusions from your data.
Absolutely.
And for you listening, we would love to hear your thoughts. Have you used the Shapiro-Wilk test before?
Yeah, tell us about it.
What are your favorite statistical tools? Let us know on our website.
We want to hear from you.
Because the conversation definitely does not end here.
Nope.
Until next time, happy analyzing, everyone.